All right, we're talking about surface area for today. So we're actually finding surface area of rectangular prisms, triangular prisms, and even cylinders. Now, there are formulas that you can follow for surface area. I'm going to teach you those formulas. However, when it comes to things like the milestones, they're not going to have a formula on the formula sheet. What the milestones formula sheet or reference sheet says, it's the sum of all areas of all faces of a net shape. Okay, so as you know, any one of your 3D shapes can be pulled apart, almost like if you think of like a 3D shape as being stitched together. And you can just pull the string, unravel it, and it's just going to lay flat as a 2D shape. That's what area is. Area is of 2D shapes. Even though we do find area of 3D shapes, we call it surface area. It's because we're actually unraveling the entire shape and just laying it out flat. So when you look at your milestones reference sheet, all it's going to say is it's just going to be adding all the areas of each of the faces together. That's it. So they're not going to give you the formulas. So you do need to understand how to find area when it's in its flat form, its net form. So that's the reason as to why I was asking you guys for these formulas. These formulas are going to be on your reference sheet, but it's always a good idea to just know what they are off the top of your head as well. So the area formula for a triangle, if we're talking about a triangle is made up of a base measurement and a height measurement that you would multiply together, just like you would do for any rectangle. You would multiply a base and a height together, but because a triangle is just half of a rectangle, you would take that formula and divide it by 2. Okay, so it does not matter. Sometimes the rectangles are right, or sorry, the triangles are right triangles. Sometimes they're not. Shh. If it happens to be written as a right triangle, then here's where your base is. Your height is that vertical measurement that makes that L shape here. Okay, if it is not a right triangle, again, your base is still that bottom line. Your height is that vertical perpendicular measurement that's going to take you from your base straight up to your highest point. That would be your height. Okay? All right, area formula for a circle. We already know that. We just finished up our circles. It's r squared times pi. Okay, remember, don't get confused with r squared versus r times 2. r times 2 is just the diameter. r squared is different. Okay, area formula for your rectangle. Again, that's just base times the height, or some people call it length times the width. Doesn't matter, either or is fine. Okay, and then the area formula for a square. Again, an area of a square is still base times height. It just happens to be that your base and your height are the same. Your base is going to be equal to your height. So you don't actually have to call it base times height. You can just say it is your base squared, because your base and your height are the exact same value. Can you stop clicking your mouse? Okay, so base squared, you know, you can say base times height, but it's important to understand that those base and heights are actually the same value. So it's your side measurement squared, or your side times your side. Okay? All right, so surface area formula. You have an overall formula for any prism at all. What it is that each prism has how many base shapes. If we're talking about a prism, so like a cylinder or a triangular prism or a rectangular prism or a trapezoidal prism, how many base shapes do we have? Base, not faces, base. We have 2 bases, right? We have 2 congruent bases. So if I'm talking about this cylinder, my little coffee cup here, okay, let's pretend that it is actually a full cylinder. This is not actually an actual cylinder, but we'll use this. This is a cylinder. Here we go. Okay, this is actually a cylinder. Okay, it has a circular top It has a circular bottom. Those circles are identical to each other. It has a rectangle that is wrapping itself around that cylinder or those circles to connect them together. So that is two bases made up with one rectangle that wraps around. So when we're talking about a formula for surface area of any rectangular prism, we have the formula 2 times the area of your base shape. Let me find my purple. Oops, there we go. So we're going to call it, we'll call it big B. 2 times big B, where big B represents the area, your base shape area. And the reason we multiply it by 2, again, is because you have two base shapes. So you're going to have two areas that you're finding the area for. Okay? Then you are going to add, I have a black one, I don't. You're going to add your perimeter, so we'll say big P, times the height, we'll say big H. And that big H is going to represent the height of your prism. That's the height of the actual prism. And P, what do you think P is going to represent? What do you think P is going to represent here, Logan? The perimeter. So P is going to represent the perimeter of the base shape. Okay, so this is your universal formula. It doesn't matter what kind of prism you have, this is going to be true for all of them. That you're going to take your base shape, you're going to find the area of it, and you're going to double that. You're going to multiply it by 2. Then you're going to take your base shape, and you're going to find the perimeter of it, and multiply it by the height that connects the two bases together. So the height of the prism means that it's going to connect, and let me write that down, connect the two bases. It'll connect the two bases together. So that measurement, because a lot of people get confused, they're like, well, there's a height of a triangle and then there's a height of a prism. What's the difference between the two? When we're talking about capital H or big H, we're talking about the height that's doing that connection, that's going to form it into a prism. It takes that one base and connects it to the next base. So it's basically the height of the rectangle that connects it. And then the perimeter of the base, that's really important to make sure you understand how to find that. That perimeter formula is different for circles than it is for any other shape. Just the same as your area formula changes every single time depending on your base shape. Okay, so that's why we call it a universal formula, that we have a universal idea of how to find them, but you have to know how to find area and how to find perimeter with the given base shape. Okay, can you take your hood off, please? Thank you. All right, for rectangular prisms, we also have a very unique formula that can go along with it. You can do this. You can do 2 times the base shape area plus the perimeter of your base shape times the height. You can do that, or you can follow along with this formula where it's 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. The reason for that is because you have 2 of each of these rectangles that are being created. You have 2 identical length by width rectangles. You have 2 identical length by height rectangles, and you have 2 identical width by height rectangles. So if you know what your length is, you know what your width is, you know what your height is, you can easily find the area, the surface area. So we'll denote my length as being pink. So everywhere I see my length, I'm going to just denote it with a pink. Okay. Everywhere that I see a width, I'm going to denote it with my blue. And then everywhere that I'm seeing my height, I'm just going to denote it with my green. Okay, now, shh. Hey guys, if you're getting your stuff out because you didn't do that ahead of time, that's fine, but just make sure you're doing it quietly. Now, again, The reason why we have 2 times this is because if I'm looking at this length by width represents this rectangle right here at the bottom, but it also happens to be the exact same one up here above it, right across from it. Those are 2 of identical length by width rectangles. Then I also have 2 of these length by height rectangles. These length by height rectangles are right here. Here's my length by my height. I have one in the very front. I have one right back here in the very back. Okay? And then you have 2 of these width by height rectangles, which would be these side ones right here. One on the side, one on this side. So you have these rectangles. You've got 2 of each type. That's why we multiply them by 2 first, and then we add all of those areas together. Okay? So if we're taking a look here at problem number 1, we have a 5 by 10 by 4. It does not matter which one you are labeling as your length, which one you label as your width, which one you label as your height, because depending on how you turn it, it will change which one is length, width, and height. Okay? But they're all going to come out the same. So I'm just going to go ahead and identify my 5 as my length. I'm going to identify my 10 as my width. And then I'll identify my 4 as the height. And then I can just plug it into this formula, this idea that I'm going to do 2 times the length and the width. I'm going to do 2 times the length and the height. And I'm going to do 2 times the width and the height. Okay? So 2 times the length, which is 5, times the width, which is 10, plus we're going to do 2 times the length of 5 times the height of 4 plus 2 times the width of 10 and the height of 4. Okay, all I'm doing is substituting these values of length, width, and height into this formula that I have here because I'm trying to find the area of all 6 rectangles that can be created here. Okay, there are 6 rectangles. I have 3 types of rectangles, 2 that are length by width, 2 that are length by height, and 2 that are width by height. So I'm just finding those areas right there. Okay, if I do 2 times 5 times 10, what is 2 times 5 times 10 going to give me? 2 times 5 times 10 is what? 100. Plus, what is 2 times 5 times 4? 40. Good. Plus, what is 2 times 10 times 4? 80. Okay, so then all I have to do is just add those together. So 100 plus the 40 plus the 80 comes out to what? 220. So we get 220, and this is meters squared, because we are talking about area. Area is always squared. Make sure you make that association. Area is always going to be squared. Go ahead and flip your paper on over to the back. I want you guys to try those 2 on your own. Alright, for problem number 2, you should have gotten 210 centimeters squared. Again, it does not matter how you split these up as long as you are consistent throughout. So I just happen to have that the 6.5 was my length. I let the 3 be my width, and I let the 9 be my height. And so then I just substituted them into the formula. 2 times my length times my width, plus 2 times the length times my height, plus 2 times the width times my height. So if I do 2 times 6.5 times 3, I get 39. 2 times 6.5 times 9 gives me 117. And then 2 times 3 times 9 gives me 54. Okay, so you should at least have those values, 39, 17, and 54. When you add them together, you get 210, again, centimeters squared. For problem number 3, it does not matter that there's fractions involved. It's still the exact same way. You just have to make sure that at the end you have your fractions converted to, the mixed number format for area. Okay, so I did 2 times 2 and 2/3 times 1 and 1/4, and I got 6 and 2/3. I did 2 times 2 and 2/3 times 1 and 3/4, I get 9 and 1/3. And then 2 times 1 and 1/4 times 1 and 3/4, I get 4 and 3/8. When I add all that together, your final answer should be 20 and 3/8. If you did not convert it into a mixed number, if you kept it improper, then that would be 163 over 8 is what you would have had. And again, feet squared. Okay, so rectangular prism, super, super easy to do. Triangular prism, basically it's following the same process, but then you divide it by 2 because your area gets divided by 2. Okay, so like I told you before, it follows this universal format where we have 2 times big B plus big P times big H, where we just discussed what each of those represents. Again, big B represents the area of your base shape. Okay, that is your base shape area. So we're just going to reiterate it one more time. Big B is your base shape's area. Capital P, that represents the perimeter of that base shape. So your base shape's perimeter. And then the capital H represented, and I'll actually do it in green then instead of the orange, so that way it just kind of sticks out. Capital H is representing the height. That's the height of the prism. It connects the two bases. Okay, it connects the two bases. It's going to be that connection between them. So for a triangular prism, in order to be able to find the base shape area, you have to know what is the base of the triangle and the height of the triangle. So the information that I just highlighted in pink is what you would use for your area of your base shape. You need the base of your triangle and the height of the triangle. To find the perimeter of the triangle, you would need to know your base, which we would then just title it side 1. You would need to know what side 2 is, which side 2 might be your height if it's a right triangle. If it's not a right triangle, then it's just the rest of your side measurements, and then side 3. So you need to know those 3 side measurements for the perimeter of your triangle. And then the height, again, the height is what's connecting the two triangles together. So I have a triangle right here and a triangle right here in the back. My height is connecting the triangles together. Okay, so again, spelling it all out for you for a triangular prism, you're doing 2 times the area of your triangle, plus you're adding your sides together and multiplying it by the height. You'll combine those units together there. So let's go ahead and do one practice problem together. The first thing that I need to know is the information for the area of my base shape. So I need to know what is big B going to stand for. So big B is the area of the triangle, which is found by taking the base of the triangle and the little height of the triangle and dividing it by 2. What is the base of this triangle? What's the base measurement on this triangle, Zach? 4. And what's the height on the triangle? 6. Good. So the base and the height on the triangle are located right here. You have 4 for the base. You have 6 for the height. That's the measurements that I need to use for the area of the base shape. So I'm going to do 4 times 6, and then I'm going to divide it by 2. 4 times 6 is 24. Divide it by 2, and we get 12. So there is our value for big B. Big B is going to just be 12. That made no sense? Okay, do you know how to find the area of a triangle? Base times height divided by 2. You know that part? Okay, so all we did was we found the base of the triangle, we found the height of the triangle, and then we multiplied. And then divided by 2. That's it. We did 4 times 6 divided by 2. We got 12. So that's the area of your base shape. So in my formula where it says 2 times big B is going to be equal to just 12. Okay, so I just solved for what big B is. Now we're going to solve for big P. Perimeter. The perimeter means that I'm going to take my side. I'm going to take side 1. I'm going to add it with side 2. And I'm going to add it with side 3. I'm just going to add my sides together. Side 1 plus side 2 plus side 3. So, what are my 3 sides? What are the 3 sides of the triangle? Everybody should be looking at their diagram and looking at what the 3 side measurements are of their triangle. So take a look, discuss with your table. What are the 3 side measurements of the triangle here? All right, come back together in 3, 2, 1. Who can raise their hand and tell me what are my measurements, my 3 side measurements for my triangle? I'm going to do somebody from a different table. Let's go with Cardin's table. Cardin's table, somebody tell me the 3 side measurements. Henry? How did you get 7s? Because I don't see the 7s here, so how do we know that they're 7s? Very good, because the 7s that are in the back, remember, the triangle that's in the back is exactly the same as the triangle that's in the front. They are identical. They're congruent to each other. So if this measurement right here is 7, then that means this measurement is also 7. And same for here. If this side one is a 7, then this side is also a 7. And of course, our base is considered to be one of the sides. That's the 4. So we're going to do 4 plus the 7 plus the 7. When we add 4, 7, and 7 together, that's going to give us 18. Any questions about how we just found perimeter of the triangle? Okay, so I know that the value P is equal to 18. So now I know what big B is. It's 12. I know what big P is. It's 18. The only other thing that I have to identify is capital H. Capital H, which is the height that connects the 2 prism or the 2 base shapes together. What is the only measurement that is connecting the 2 triangles together? Hassan? 12. That 12 is the value that connects between the 2 triangles. Okay, I'm taking the bottom right corner of the first triangle and connecting it to the bottom right corner of the second triangle, and that measurement that connects them is the 12. There's no calculation that you have to do there. You just have to identify it. Okay, and now that we know this information, we can plug it into our formula. We can do 2 times big B, right? 2 times big B, so I'm going to do 2 times 12. I'm going to add it with the value for my perimeter, which was 18, times the value of my height, which was 12. Okay, so all I'm doing now is just substituting. I'm substituting now into my formula. 2 times big B plus P times H. Okay, 2 times that 12. 2 times 12 is going to give us 24. Plus 18 times the 12. 18 times the 12 is going to give us 216. And then I'm going to add those together. 24 plus 216 comes out to 240, and that's centimeters squared. So again, it helps. It helps if you just break your formula apart step by step. Go, okay, I'm going to find the area of my triangle first. Then I'm going to find the perimeter of my triangle. Then I'm going to find the height that connects my two triangles together, and then I substitute it into my formula. Go ahead and do the next two on your own, the next two triangular prisms on the page 3. Let's take a look here. For problem number 2, you should have gotten 672 centimeters squared. Let's take a look at the y. Okay. Again, we're finding the components of our formula. So we're finding what the area of the base shape is first. So we have to find the area of the triangle by doing base times height divided by 2. The base of the triangle was 12. The height of the triangle was 16. So we're doing 12 times 16 divided by 2. That's a mistake right here. I had multiplied it by 2 already. So that should come out to 96. So your area of your base shape is going to be 96. Then we're going to do the perimeter of the base shape. So we're going to add all 3 sides of our triangle together. So we're adding 12, 16, and 20, and that gives us 48 for the perimeter. The height that connects the 2 triangles together is the 10. So then we just substitute it into our formula. We're going to do 2 times the 96 to get us 192. We're going to do 48 times the 10 to get us 480. Then we're going to add those together to get 672 centimeters squared. Yes, sir? I don't want you to get into the habit of thinking that you don't ever have to divide by 2, because if you get into something like a pyramid, it's a different formula. And so then if you start thinking that you never have to divide by 2 with triangular values, it's going to mess you up eventually. So you want to make sure you stick to the idea and knowledge that triangles are always divided by 2 for area. Okay? All right. Same thing for number 3. Area of the base shape. Again, I made my mistake here. Area of the base shape, we're going to do 9 times 12, divide it by 2, because 9 is the base, 12 is the height, and then we divide by 2, we get the 54. The perimeter is just adding all the sides, 9, 12, and 15 together to get 36. The height that connects the 2 prisms, or the 2 triangles together, is that value of 6, and we plug it into our formula. 2 times 54 is 108. 36 times 6 is 216. When we add them together, we get 324 meters squared. Okay, so that's our triangular prisms. We do have cubes that we need to focus on as well. And remember, I told you before, a square has, yes, a base times height for the formula, but we also can focus on it as just the base times the base, because the bases are the same. And it makes the surface area formula of a cube that much easier, because all you have to do is find the area of one of the squares, which is the side times the side, and then multiply it by 6, because you have 6 identical faces when you're talking about a cube. So a cube has a very unique formula that you just find the area of one of the squares and then multiply that area by 6, because you have 6 identical squares that make up a cube. Is that understood? Okay, so again, the side, also known as your base or your height, whatever you want to call it, they are identical. So when we are looking here, my side measurement, if I'm talking about my side measurement, doesn't matter which one I'm choosing, they're all the same. My side measurement in this case is a 10. So I'm just going to do 10 squared and then multiply that value by 6, because again, we have 6 of those squares here, right? I've got a square located right here. I've got another square located here at the bottom. I have another square off here to the side. I have another square up here at the top. I have another square right here at the front. And I have another square off to here off the side. I have 6 total squares that I can count. 1, 2, 3, 4, 5, 6. Okay? All right, so we have our 6 squares. So we're multiplying the area of the square by 6, and that's going to give us 600. And that is centimeters squared. Okay, doing the same thing here for this cube. This cube, again, has a side measurement of 3. It doesn't matter which side measurement you're choosing, because they're all the same. So you're just going to do 3 squared and multiply it by 6, because you have 6 identical squares. So 3 squared is 9. 6 times 9, that's going to give you your 54. So you have 54 centimeters squared. Okay? Any questions for that? All right, let's go on to the newest one that you guys have to learn about, which is for cylinders. And again, cylinders, same idea, same concept. Surface area of a cylinder, you have two circular bases. So you're finding the area of your two circle bases. But then instead of us saying perimeter, we are finding circumference and multiplying it by the height. So we have two base areas, and then the circumference happens to represent the base of our rectangle, and then the height of the cylinder represents the height of the rectangle that is wrapped around to form that cylinder shape. So that's where you're going to get these two values here together. So again, we're going to do 2 times the area of our circle plus, we're going to now take our circumference, C, circumference, and we're going to multiply it by the height of the cylinder. Okay? All right, so let's start off with problem number 1, finding the area of those base shapes. So, still going to write it as capital B. Still going to write it as capital B, so we're going to find the area of the circle, which is found by taking pi r squared. We're just going to do 3.14 times the radius squared. The radius in this case happens to be what? 3. The radius in this case happens to just be a 3. So we're going to do 3.14, and we're going to multiply it by 3 squared. So 3.14 times 3 squared. That's going to give us 28.26. So there's what capital B stands for, 28.26. Okay, the perimeter is just our circumference formula. So the perimeter is going to be diameter times pi. So the diameter happens to be what? 6. The diameter is 6, and we're going to multiply that by 3.14. That's going to come out to 18.84. Okay, and then the height of the cylinder happens to just be the 9. So then we're going to plug it into our standard formula. We're going to do 2 times big B plus perimeter, or in this case, circumference, times the height. Okay, so 2 times 28.26 plus the circumference, 18.84, times the height. Jeremiah, you copying? Okay, so if we do 2 times the 28.26, it's going to give us our 56.52. And then if we do our 18.84 times the height, I didn't even put down the value of it, which was supposed to be a 9. I'm supposed to change that to a 9. My bad, guys. If we multiply those together, that's going to come out to 169.56. And then when we add the 56.52 with that value, that comes out to 226.08, and that is inches squared. Okay? Go ahead and do problems 2 through 4. So here's just the answer for problem number 2. Radius is 7. That means the diameter is going to be 14. So we're going to do the area of our circle first. We're going to do 7 squared times 3.14 to get 153.86. The perimeter, which is basically the circumference, is the diameter times pi, 14 times 3.14 to get 43.96. Height is 11. And then we plug it into our formula. 2 times 153.86 comes out to 307.72. 43.96 times 11 comes out to 483.56. Combine those together, you get 791.28 meters squared.